Good morning. Welcome to the third lecture of 7th week of this ongoing course on understanding and reducing greenhouse gas emissions, and we are focusing on building design and construction for reduction of emissions, especially scope 1 and 2 emission. Today we are going to look at reduction of emissions from purchased electricity. Now, what we have seen in the previous lecture and almost the entire week of lectures before that is that we have been looking at different strategies of building design and construction to reduce the emissions. So, we looked at passive design strategies, we looked at advanced passive design strategies, we looked at natural ventilation and daylighting strategies. Now, all these were actually going to impact the operational energy, the scope 2 emissions directly. Then we looked at building materials. So, what are the factors that govern the selection of building materials for a particular building, and then we looked at the emissions related with different materials. So, we are talking about carbon emissions here. Now, together when we put all of this in perspective, what we are seeing is that we are reducing the scope 1, 2 and 3 emissions downstream, largely these. So, we are reducing the scope 1, 2 and 3 emissions, and within scope 3 we are largely looking at the upstream emissions, and we were trying to reduce that through reduction, through demand reduction of operational energy. Now, by doing that, doing all of this, we would have reduced significant amount of operational energy requirement, that demand, and hence the scope 2 emissions associated with that. Now, this little amount of energy that is required in the building after a significant demand reduction, today in this lecture we are going to talk about that. So, what are the options? So, we have electricity produced from conventional fuels, and then we have electricity which is produced from a lot of different renewable sources, and that is what we are going to see, that how much is the carbon footprint or the emission intensity of the energy produced using renewable sources of energy, and how can we incorporate that. So, you would have seen a lot of discussion is around where we know how to integrate renewable energy into the buildings at a very small scale, and we are also looking at the nation and society at large incorporating renewable sources of energy into the main grid and making this grid more sustainable and reliable. So, today what we are going to see is what all are these sources, what are the carbon footprint of these different types of sources. So, there is a lot of discussion when we start discussing about these different sources of energy, that what is their carbon footprint, what are the emissions associated with it. So, is it just operational energy that is, or the emissions related with operations that are reduced, or on a life cycle basis the emissions are reduced. And then we will look at specifically the national power grid of India and what are the potentials for replacing the conventional with renewable sources, and looking at the global scenario as far as the sources of this power energy are concerned. So, starting with the global share of GHG emissions from electricity. So, if we look at the overall greenhouse gas emissions worldwide by different sectors, by subsectors, we can clearly see that the maximum amount of emission is actually coming from production of electricity. And where is this electricity going? We have seen that a lot of this electricity, a significant share of this electricity is actually getting consumed in buildings. So, what we are seeing here is that electricity produced using coal plus electricity produced using gas and electricity produced using oil together is constituting around 25 to 30% of the total emissions of the world. And of this almost 25%, we are looking at almost 35 to 40% of this energy going into buildings only for creating comfort, and that is what we have been talking about. In addition to that, you can clearly see that 5% of this energy is also going in residential buildings, and then we see a lot of different industries. We see road transportation featuring in, which is going to come under the purview of architects and planners. We are also seeing commercial buildings and also the emissions due to refrigerants in buildings. So, we are talking about fugitive emissions here. together we see that electricity and the consumption of fuel and a lot of other processes within buildings are responsible for significant share of the overall GHG emissions in the world. So, electricity becomes extremely important, the source of electricity becomes extremely important. Now, what are the different sources of energy? Now, here when we saw the share of different subsectors in GHG emissions, we saw that the renewable sources of energy, the electricity produced using them, does not feature in here, it does not create, it does not contribute to GHG emissions, and that is what we are going to see. But before that, let us look at the main sources of energy. So, the main sources of energy can be classified into two main baskets, one which are non-renewable and the other ones which are renewable. Very clearly, I do not have to go in detail over the discussion where we understand what is renewable and what is non-renewable, but here clearly what is non-renewable is a resource which when consumed is going waste, it is changing its form, it is rendered unusable henceforth, and the nature cannot reproduce this particular resource, this source of energy within a short span of time, it cannot renew it. So, that is non-renewable, and the renewable is the one where even after producing energy using this particular resource, the resource remains more or less intact, or it can be replenished by the nature in a very short span of time. So, when we say non-renewable, we are looking at radioactive materials there, but the common understanding and the predominant non-renewable source of energy that we are currently using, the world is at large using, is the hydrocarbons or fossil fuels. So, we are extracting these fossil fuels which are carbon rich from underground, and then we are burning them, we are combusting them to produce heat, which is in turn used to produce electricity. This is the whole cycle, and we are looking largely at the hydrocarbons and fossil fuels. Now, in renewable sources, we have multiple options, and depending upon the availability, the geographic availability of each resource, this resource can be utilized. So, the limitation with renewable source of energy is that it cannot be transported. So, what are the renewable sources? We have hydropower, we have tidal power, geothermal, wind, solar, biomass. So, these are the main, these are the prominent sources of renewable energy. Now, if you look at this, none of these resources can be transported and transferred from one side to the other side. So, they are geography dependent and they are also season dependent. They also have diurnal variation. For example, solar energy, it is not even available 24 hours a day. It is available only for the duration when the sun is there. If you talk about, say for example, hydroelectricity. So, hydropower cannot be generated everywhere. There has to be one sufficient availability of water, and we also have to have a terrain where a significant level drop is available and the water can be used to produce, to run the turbines to produce electricity. So, this is again specific. Tidal energy is only in the coastal areas, oceans where significantly intense tides are coming, that is where tidal energy can be produced. Geothermal energy, again where we have an access to the heat of the ground underground, and it can be used to run the turbines, to heat up, to make steam and then run the turbines. Same as with wind energy, we have to first undertake a proper feasibility study to know that how much of the wind is possible or is available, and is it sufficient enough to run the turbines and to produce electricity. So, overall the limitations are there with renewable sources of energy, and that are the geographic limitations and the seasonal or diurnal limitations, limitations of time when they are available. The advantage with the non-renewable sources of energy was that they could be transported from one place to the other, from one geography, from one region to the other region. They could be burnt, they could be combusted, and the energy can be produced where it is required. So, locally it could be provided. Now, with renewable sources of energy, it can also be produced locally. In fact, it can only be produced locally, but only where there is this availability of resource. So, there could be places where none of these is available, where there is no there is no potential for hydropower or tidal or geothermal, wind, or sometimes even solar is not possible. So, in such scenarios renewable may not be a possibility. However, such regions, such geographies are rare on earth where none of this is possible. Often one or the other is usually possible. Now, we look at the global distribution of how much percentage of energy, electricity is produced using each of these sources. We will see that almost 80% of the total energy is produced from non-renewable sources of energy. We are looking at crude oil, we are looking at coal, peat, we are looking at natural gas. So, we are looking at 80% of the energy being produced by these three, and these are all non-renewable sources of energy. Even nuclear energy is non-renewable source of energy, it cannot be renewed, but the amount which we are using is minuscule in proportion to the energy that it produces. However, it will still be counted as a non-renewable source of energy, and we are looking at more than 85% of the energy of the world still being produced using non-renewable sources of energy or conventional sources. Only a small percentage of the total global energy is coming, close to 10 to 15% is coming from renewable sources of energy today. The world is moving very fast. However, this data is probably from 2018 and we have moved further. The world is very fast shifting to the renewable sources of energy, because we are seeing that we are depleting the conventional sources of energy, the hydrocarbons and fossil fuels at a much larger pace, and they are not going to last for a long time, probably not even this century. That is one. Number two is that the burning of these conventional fuels, fossil fuels, is the prime reason for global warming, the greenhouse gas emissions, and that we have been discussing throughout in this course. So, for both the reasons we are shifting to the renewable sources of energy, and the different types of energy sources, renewable sources of energy that we are discussing here. So, I am not going to go in detail over them, and I expect you to be knowing these, but still giving you a quick brief overview of what these are. So, when we say that hydropower, we are actually using the gravitational potential energy of water, which is then converted into electrical energy through turbine. For wind energy, we are converting, we are doing the same process, just that we are, instead of gravitational potential energy of water, we are using kinetic energy of wind, and then we are converting it into electrical energy using the wind turbines. For solar energy, we are using sun's energy. Sometimes it is the heat and the other times it is the light, and then it is turned into electricity by solar panels or solar heaters or the concentrators. So, solar energy could be two types. It could be thermal, solar thermal, where we are using the heat of the sun and then using it to make steam and then run turbines, or we could be converting it into electricity using photovoltaics, where we are using the light from the sun's energy. Now, when we are talking about biomass, we are actually, it is similar to the conventional source of energy in the sense that it is going to be burnt, it is going to be combusted, and the heat thus produced will be used to produce energy. So, what we are using? So, it can be again used in two ways, one to produce heat, or we can also use it to produce electricity. So, we are using the heat stored in these materials, which is going to be procured from burning the biomass, for directly heating or to produce electricity. When we are talking about geothermal energy, we are using the heat which is trapped underneath the earth crust to convert into electricity. So, that is geothermal energy. In ocean energy or the tidal energy, we are using the oceanic thermal and tidal energy to be converted into electricity using again turbines largely. And another one which is becoming more of a research interest, and there is a lot of focus of the world on this last source of energy, is hydrogen. The potential of hydrogen to convert chemical energy into electricity through fuel cells, hydrogen fuel cells, is being explored. So, currently there are a lot of issues, challenges which are being resolved by researchers. So, it is very easy to procure hydrogen, but it is very difficult to transport, to store it and transport it, and then we need to transport hydrogen. We can't be producing the energy then and there, with the challenge that it is highly combustible, inflammable. So, these challenges are being resolved, and with the way researchers are going forward, very soon we would probably see hydrogen being available as the most potent renewable source of energy. So far we have the remaining 6 which are currently in commercial use. The 7th one, hydrogen, is not in commercial use, but a lot of research is going on. Now, if we compare the carbon emissions of these various sources of energy, so here we are looking at the conventional sources of energy or the hydrocarbons, fossil fuels. So, we can clearly see that the least emissions are caused by natural gas, and that is 500 tons of carbon dioxide equivalent per gigawatt hour of electricity produced. So, we are looking at this range starting from 500 and going to approximately 1000 tons of carbon dioxide equivalent per gigawatt hour electricity produced. This is what we are looking at when we talk about the carbon emissions. Now, if we look at the renewable sources of energy and we compare the carbon footprint of these renewable sources of energy with that of the conventional sources of energy, we see the least emission causing source of energy as wind. Now, these numbers are subject to change, slightly different for different contexts, different geographies, economies. So, these numbers are not sacrosanct, but they give you a clear idea of the number that we are comparing. So, natural gas would give us 500 tons of carbon dioxide equivalent emissions per gigawatt hour of energy produced. Now, here when we are looking at wind, onshore and offshore, and this number will also change. Some places you will see that the offshore wind is significantly lower, it has a lesser emission intensity. In some other cases you will find onshore has a lower number, but whatever this number is, it is approximately in the same range, which is 12 grams of carbon dioxide equivalent per kilowatt hour, which is coming to approximately 12 kilograms of carbon dioxide equivalent per gigawatt hour. Now, what are we comparing? We are comparing 1000 to 500 tons of carbon dioxide equivalent per gigawatt hour compared with that of 10 to 20 kilogram, 1000 tons versus 20 kilogram of carbon dioxide equivalent per gigawatt hour of electricity produced. This is the difference, and this includes, this takes the entire life cycle of the production, the material that has gone in. So, the upstream scope 3 emissions, the operational requirements, the minimal, there is very insignificant amount of emissions that are caused during the operation phase of these modes of producing electricity, overall throughout the life cycle, and also the downstream. So, overall what we are really seeing here is a significant difference, 1000 times reducing the emissions using renewable sources. If you look at solar, so different types, concentrated, so concentrators, solar thermal, roof, utility, all of them, they are also almost 50 times less or 100 times less emission causing than the conventional sources of energy. So, we see with all of them except biomass, biomass is also significantly lower than the conventional source of energy, the hydrocarbons or fossil fuels, but comparatively larger, much larger than all other sources of renewable energy. And if the numbers are to be believed, if we are looking at hydrogen, so where we are seeing the minimum or approximately coming to 20 to 50 kilogram of carbon dioxide equivalent, hydrogen would probably give us only 1 to 2 kilogram of carbon dioxide equivalent, CO2 equivalent of emissions per gigawatt hour. It is going to be that clean. However, the challenges still need to be resolved. So, we still do not know whether it can be transported or the medium is going to be emission causing or not. But as far as the existing sources of energy are concerned, and we are only talking about carbon footprint. So, there is a lot of discussion besides carbon footprint also. So, another thing that we have to discuss here, we have to know here is that all this discussion that we have been having and throughout the last 6 weeks and this is the 7th week, we are discussing about the greenhouse gas emissions, we are talking about the carbon footprint. We have based or we are basing most of our discussion on the amount of emission, greenhouse gas emission that these activities are going to release in the air. We have not even thought or discussed about what is the water footprint. So, the moment we say solar has a very low carbon footprint, it indeed has, but it has a significantly high water footprint, because a lot of, so the photovoltaic has semiconductors embedded in that, and semiconductors are known to have extremely high water footprint. So, if we are only looking at GHG emissions, the carbon footprint with these renewable sources of energy are significantly lower, they are much lower. And today, since we are discussing this course, and why are we discussing this course is because global warming is a reality, it is creating havoc on the planet Earth and we need to control it immediately, though this is not a sustainable thinking. So, what we are seeing currently is, let us resolve this issue of energy and the emissions first, and but we also have to simultaneously look at the other resources that are being consumed in the process. So, if you compare all these sources of energy on their carbon footprint, plus we add probably water footprint or other footprints also, we would be able to make a better choice, a judicious choice of which source of energy is going to be least environmental, having least environmental impact. As far as carbon footprint is concerned, all these sources of renewable energy are a better option than the conventional sources of energy, depending upon their availability. So, again we can look at these numbers, they usually have, most of them, whether it is wind, solar, hydropower, geothermal and biomass, all of them have one time upstream emission related with them, because most of these they require infrastructure to be set in place. When we are talking about wind energy, huge wind towers or wind farms, they need to be set up. If it is offshore, in that case the base making, the transportation, everything, it is a one time emission causing activity, the upstream emissions. If we are looking at hydropower, the large dams that are being designed and constructed, they will all have very high one time upstream emission that is going to be there. And once it has been commissioned, it has been put in place and in use, after that the ongoing combustion, the ongoing emission is practically zero. It is only going to produce energy at zero emissions throughout its life cycle, and in the end the one time downstream emission for a lot of these projects which have been constructed across the world, majority of them have not been taken down so far. Once they were installed, for example, the dams for hydropower, once they were put in place, they were constructed and they were up and running, they have been running since then. So, their life cycle is also very long, and majority of them have not been demolished, and there is very little data that is available for the downstream scope 3 emissions, which is associated with the demolition and disposal of the waste. So, most of these having fairly long life cycle and having very less emissions overall. Even after including upstream and downstream, they are going to be much less emission causing. If we place all these sources of energy, so we saw the non-renewable and renewable, and if we put all of them in one graph, this is what we are understanding. So, wind and nuclear is not renewable, it is non-renewable, and as I clearly said that renewable still, the nuclear still causes significantly lesser amount of emission due to the processes that are there. So, wind and nuclear, they are at the bottommost when we are looking at the emissions, and the emissions caused due to electricity produced using coal is much higher than all of them, almost 1000 times higher is what we are looking at here. All other renewable sources of energy are also significantly lower than all the conventional sources of energy is what we see. Now, coming to national power grids of India. So, what we have currently is that we have 5 major grids in which the entire country is divided, and we still draw a significant proportion of this electricity which is running in the grids from the non-renewable sources of energy. India is doing significantly better. We are reaching almost 50% of the energy which is generated from renewable sources today. Now, what happens if the grids were to depend entirely on renewable energy? As I said that the renewable sources of energy, they have limitations in terms of geography and seasonal and diurnal variation. So, sometimes probably during the nights, if there are no winds, if there is no sun, if there is no availability of hydropower or tidal, we may not be having a continuous supply of energy. So, the best option in this in such a scenario is to have a mixed portfolio of renewable energy and backed up with a conventional energy for sustaining the growth. So, we are not just looking at reducing the greenhouse emissions, we are also looking at sustaining the economy, sustaining the growth simultaneously. So, what we are doing in conventional, if we omit this part of the energy supply, this entire grid. So, we produce, it goes to the transformer or the storage facility, and through that it goes to the transmission tower and substations, through tower lines into the utility where it is going to be used, the homes, businesses, industries, everywhere. So, these are the end users where this is going. Now, this is conventionally how electricity is being supplied in our country. Now, what we have to do is that we have to have localized and mix of different sources of energy to supply energy directly at the local level into the grid and then to the end user. That is what we are, that is what is going to sustain in the long run. So, what we see, if we look at the entire map of India, and it is divided in 5 grids. So, we have the northern grid, western grid, southern, eastern and northeastern grid. Each of these grids has a potential for renewable source of energy. If we look at northeastern, it has a significant potential for high hydropower, hydropower potential. If we look at the eastern, we have very high coal reserves and it is a power surplus region in general. If we look at southern, so it has hydropower, but it is dependent on monsoon. So, it varies seasonally. Solar is more or less available in all the 4 regions except the northeastern region and the extreme north of northern region. So, solar is available more or less throughout the country, and if you are looking at northern region, it has the potential for hydropower, which is snow fed run of the river, and this hydropower is also sensitive to weather. So, the output of electricity using these is also dependent upon weather. So, what we have, and in addition to that, this is for hydropower, we have the potential for wind energy, we have the potential for tidal energy which is now being explored and also harvested, and we have a tremendous potential for using solar power plants, using solar power, using photovoltaic as well as solar thermal, because throughout the year we have more than 260 sunny days where the sky is not overcast in majority of the geography of India as a country. So, what we see from here is that we have this potential, we are also using this potential, and today we see that we have almost 36% of energy share as renewable energy, and this is as on March 2020. And if we look at the current numbers of 2022 publishing, we are closing in on 50-50. So, 50% of the total energy used in India being produced using conventional sources of energy, and the remaining 50% being produced using renewable energy, and this I am talking about installed capacity which is already working. A lot of projects of solar power, of hydropower, they have been sanctioned and they are under construction or they are going to be installed very soon. So, as India committed to itself, by 2030 we promise to have a 50% mix of energy coming from the renewables, and we are likely to achieve that target much ahead of the promised deadline. What we have to also see with renewable energy is, as we were seeing when we were seeing the total emissions, is that the one time the upstream emissions are very high with most of these renewable energy projects. So, different countries have different policies, but very large projects of energy producing, they are put in the conventional or non-renewable source of energy, for example, very large hydropower plants. So, they in India they are considered as renewable source of energy. In many countries they are not considered as renewable source of energy, because though the water is renewable and the energy that will be produced will have zero emissions, but it is such large projects are associated with very high environmental impact. They displace people. So, there is a lot of rehabilitation that has to be done. So, the social impact is very high, the environmental impact is very high, though the emissions are significantly lower, but other environmental impacts are higher and social impacts are higher. So, such projects in some countries, sometimes sometime back even in India they were considered as, they were not considered as renewable, but now we consider them as renewable, and today our energy supply from renewable sources stands at very close to 50% of the total share, which is a very good number. And if we look at the share of that, we will see that hydropower and solar are the most significant sources of renewable energy in our country. Within solar, if we see, we have both large scale solar and we have rooftop solar. Now, both these large scale solar or rooftop solar, they have been made possible, they are enabled through policy. So, policy as an instrument has a significant role to play whenever we are talking about renewable energy and the shift to that. If we look at the global scenario of energy consumption, we will see that the overall consumption of energy specifically in Asia Pacific is increasing. So, this portion is significantly increasing, in fact this. So, this is what we are seeing, that in Asia Pacific the energy consumption is significantly increasing, and that is why, because the industrialization came later into the Asia Pacific and it is now happening. So, more and more industries are being set up, and those industries require a lot of developmental activities are happening in Asia Pacific right now, and which is why we require a lot of energy, and which is also resulting in a lot of emissions, and it is still growing, the graph is upwards. Of this energy that is consumed in the world, we still see, and we have seen this percentage breakup, most of the energy is still coming from the non-renewable or conventional sources of energy. A very small 10 to 15% is coming from the renewable sources of energy. If we look at some of the countries, the top 10 countries which are producing electricity from fossil fuels, we see that the electricity is still being produced largely using coal, gas and oil. And if we look at the countries which are doing very good as far as the use of renewable sources of energy production are concerned, then we see that India, so this is again 2021 data, as on 2023 India is at number 4 and we are doing very good as far as the renewable energy consumption is concerned. So, as a country we are doing very good, we are shifting, we are moving forward to the renewable sources, and besides the country moving towards renewable sources of energy, what we also have to see is that there is a lot of potential to include this in the building design itself. Solar is the most convenient, easy to use form of renewable energy. So, we have solar photovoltaics, we have solar thermal concentrators and we have solar heaters. So, for supplying energy requirement, the electricity inside the building, for supplying the hot water or heating in the space, for all these three purposes we can have energy producing assemblies right on the rooftop. So, solar is one. The second most convenient, but of course, in certain geographies of the country is the wind energy. So, we do not need to have very high masts and huge turbines. There are micro wind generators, micro wind turbines which are available, and that can be installed on top of your terraces, provided we have sufficient wind velocities to run those turbines. So, what we are looking at is, of course, the country is making a shift, but we as building designers and managers have to shift, have to start generating our own electricity, so much so that we become, each building becomes net zero energy requiring building. So, first we reduce the demand and then we are supplying the demand by installing the energy producing equipment on our own terraces and also having a mix. So, multiple sources of renewable energy is what we are talking about. So, with this I will stop here, and we have fairly looked at the different aspects of reducing emissions through building design and construction, looking at the design strategies, looking at the construction strategies, that is demand reduction plus supplying it through renewable sources of energy. In the remaining lectures of this week, we are also going to look at the retrofitting and refurbishment of buildings. So far what we have been talking is with the perception of new buildings, with the mindset of new buildings being constructed, but a lot of building stock still exists, and how we can make it less emitting or less emission producing is what we are going to see in the rest of the week and few case studies before we move on to the calculations. How much emission reduction are we really getting through each of these strategies is what we will see in the next week. So, thank you very much for joining me here today. Bye bye, see you tomorrow.